Hey everyone, so on this video actually I'm going to talk about a question that involves a few things altogether. So this is a question. So we are given a right triangle and we have a angle bisector in that right angle, and we just like to find 1 over AB plus 1 over AC. Okay, so it's not really clear what to do with this problem if we don't really draw the picture, so that's why I'm going to just go ahead and start drawing a right triangle. Okay, so let me go ahead. So let's say this is our right angle triangle, and since we are told AB is perpendicular to AC, so if AB is perpendicular to AC, A is a common, so that means A needs to be that right angle. So this could be B and this could be C, which tells me AC and AB are perpendicular. So this is gonna be our 90 degrees. And actually, we are told ABC is right triangle, okay, and AD is angle bisector. So A right here, D has to be on BC. So that's why I'm gonna just go ahead and draw my angle bisector. So let's actually do that. And this is gonna be our AD. So I'm gonna call this is D. And if this is angle bisector, this needs to be 45 and this needs to be 45. Okay, and if AD is 1, so this is 1, and what is the ratio of 1 over AB plus 1 over AC? Okay, I'm going to call this is A, and I'm going to call this is B. So the question asking us 1 over A plus 1 over B. Okay, this is a bit trickier. We just like to know A and B maybe, and if we can find them, we can just find 1 over A plus 1 over B, but it doesn't look like we really need to find A and B. So I just like to combine these two fractions before we let's start actually. So if I multiply this by B and this by A, so this is going to be equal to A plus B over AB. So this is actually something we might try finding A plus B over A times B. So maybe that is what we are looking. So I'm going to leave it for now for this part. So let's see what we can do with the given problem. So first of all, since we are given angle bisector, and I may use angle bisector theorem, but in this problem we are not really given a lot of information, so we don't know BD and DC, so it doesn't really help us to use angle bisector theorem. So that's why I'm going to think about something else. So I do believe we may use area for like sine. Okay, so if you are not familiar with that, so whenever you are given a triangle, actually let me try to write it here just to be clear. So we have a few different ways to find the area of any triangle. One of the ways is actually using sine formula. Okay, so it's whenever you are given any triangle, let's say this is A, B, and C, let's say this is the angle alpha. So if you are given a angle and two sides just around that angle, let's say this is B and this is C. If I want to find the area of this triangle and two sides are given and one angle in between those two, actually not one angle, the angle in between those two sides, the area is 1/2 times B times C times sine of this angle. So sine of that angle. So if you are not familiar with the some trig functions, sine is one of those. So this is also something you need to work on it. So the sine is basically a ratio of side opposite to given angle divided by hypotenuse. So, but in order for us to use sine, cosine, or tangent like trig functions, we should have right angle triangle. So let me actually write it here as well. So let's say we have a right triangle. These are just background. So if you are not familiar with these, so I will say go ahead and work on those two topics. Okay. So let's say this is alpha. I'm gonna call this is A, this is B, this is C. And if this is C and this is B and this is A, so sine of alpha basically means opposite of this angle which is C, divided by hypotenuse, which is A. So sine basically ratio of the opposite side of divided by opposite side divided by the hypotenuse. That is the sine of any given angle. So if this angle is 45, okay, alpha is 45, so this is gonna be same as this one. So this is, let's say, 1, this is 1, this needs to be root 2, so 1 root 2, so the sine of 45 will be 1 over root 2. So let me just write it as well. So sine 45 is 1 over root 2. Okay, so I'm gonna just be using this in this question because we are told one angle right here, and now we are looking for something related to this side, and this side is given, and this is given, and we are looking for something about this side as well. So which reminds me that maybe I can use area formula by using sine. So the area of the ABC, I'm gonna write it here, ABC. So when you see this notation, that means area. I'm gonna find the area of this ABC in two different ways, and that area should be the same. So first way, since this is a right triangle, I can multiply A by B and take the half of that, so that should be A times B over 2. And at the same time, I can actually, let's do this way. I'm gonna find the area of this larger triangle by finding each area and adding those together. Okay, so the area of this ABD, so that should be, okay, let me actually clear this one. The area of the ABC will be ABD, so ABC is going to be ABD plus ADC. Okay, so ABC is AB over 2, and ABD is 1/2, okay, based on the sine formula that we were talking right there. So 1/2 times A times 1, so that should be 1 times sine 45. So we do know sine 45, 1 over root 2, but let's leave it for now. And plus the same thing, area of this triangle, 1 times will be, but we should have 1/2 for sure. So that should be times B times sine 45. So since we have all like fractions that has a denominator of 2, let's multiply everything by 2. So that looks like we have AB is equal to A times sine, actually let me convert that to actual value, A times root 2 over 2. So when you multiply this by root 2, so that should be root 2 over 2, and plus this is gonna be B times root 2 over 2. So again, this is just same as 1 over root 2. So when you multiply by root 2 for numerator and denominator, this is what we get. And I have now A times B, which is something we were looking. I have A plus B right here, but we have root 2 over 2, which is something makes it a little bit confusing. So I'm going to take root 2 over 2 as a common factor. So if I take this one, I'm going to have A, and then I have plus B, and this is equal to AB. The question asks actually A plus B over AB. So I have AB right here, A plus B right there. So I'm going to divide both sides by AB. Okay, so I'm going to divide this by AB, and this is going to be divided by AB. When I do that, I will get root 2 over 2 times A plus B over AB, which is something what we are looking, but we do have something in front, so which is something I need to get rid of somehow. So I'm gonna multiply this by 2 over root 2, okay, and I'm gonna, actually we don't have to really convert this 1 over root 2, let's leave it as that way, okay, so because that will be easier to work with. So this was 1 over root 2, and this was 1 over root 2, and this is 1 over root 2. So what I'm going to do now, I'm going to multiply both sides by root 2 over 1. I'm going to multiply this by root 2 over 1 as well. So AB's will cancel, root 2's will cancel. So on the right side, a plus b over ab is the only expression that we have. On the left side, we have 2 over 1. So which tells me a plus b over ab is equal to root 2, which is indeed our answer A. Okay, so that should be our answer.